Hello everyone, welcome back to Study with Mo. Today we are going to cover the 062041 paper, October-November 2024 for Chemistry, Theory Extended. Starting with the first question, it's really similar to the last papers, October-November's. A list of chemical and physical processes, A to H is shown. A, combustion. B, diffusion, melting, neutralization, photosynthesis, reversible reaction, roasting, thermal decomposition. So we gotta answer the following questions about the processes, and we either use the letter once, more than once, or not at all. So A happens when an acid reacts to an alkali. That's obviously going to be neutralization. B reaches a position of equilibrium. That is going to be reversible reaction. Involves particles changing from fixed positions to being mobile but still touching. That is not really diffusion, it is melting. D are physical changes. B and C count. Is caused by gas particles colliding with each other. That is going to be diffusion. Second question is about the atomic structure and the periodic table. Find the term nucleon number. So nucleon number is basically the number of nucleons of an atom. And remember that in the nucleus there are only the protons and neutrons. So proton and neutron number in the nucleus of an atom. State the connection between the number of occupied electron shells in an atom and the period number of the element. They are equal. Write the electronic configuration of the following atom and ion. So you got silicon here, 2814, the electronic configuration. We count using the number of protons, but for Cl, since it has a minus, that means it has an extra electron. So 288, 284. Complete table 2.1. We can see the atom or ion. The first on the left, the top number on the left is the nucleon number. The number on the bottom left is the proton number. And the electron number can be further suggested by the minus or plus on the right. It either indicates whether it has an extra or one or three less electrons. So if it's a minus, that means it has an extra electron. If it's a plus, that means it has less electrons. So 12, 11, 10, and for gallium, we can just use the number of protons because the number of neutrons or the number of electrons is actually variable. The only unvariable part is the number of protons. Sample of thallium Tl contains 2 isotopes, 203 Tl and 205 Tl. Define the term isotopes. So isotopes are basically different atoms of the same element with different neutron numbers. So atoms of the same element is a key point here, and different neutron numbers is another key point. The relative abundance of 203 Tl, 205 Tl is in the ratio 3 to 7. So we can see here that this question employs your knowledge of the relative atomic mass, the definition of the relative atomic mass. So it's basically the average mass of an atom compared to 1 over 12, the mass of 12C6, which is carbon. So here we got the two atoms, so we just multiply their MRs with their ratios, corresponding ratios, and then divide by the total amount, the sum of their ratios, which is 10, giving us the relative atomic mass. Suggests why these two isotopes have identical chemical properties, same electronic configuration. Copper 2 sulfate has a formula CuSO4. Aqueous copper 2 sulfate is a blue solution. A sample of aqueous copper 2 sulfate is made by adding excess copper 2 oxide, CuO, to hot dilute sulfuric acid H2SO4. Complete a symbol equation for this reaction. Include state symbols. So CuOS, H2SO4, aqueous, CuSO4, aqueous, and we know the only liquid that is considered as liquid in chemistry IGCSE is water, so that would always be H2O. And if you didn't know about that, you could see that CuO is an alkali, H2SO4 is an acid, so an acid and an alkali make for a neutralization reaction, and a neutralization reaction always produces a salt and water, so you could also use that to get the answer for H2O. State one observation which shows that copper 2 oxide is added in excess. So there's either there either is remaining solid or no more solid dissolves. Describe how aqueous copper 2 sulfate can be separated from the reaction mixture. Filtration, because there will be remaining CuO. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. Say what is meant by the term hydrated. Substance that's chemically combined with water. So they can also ask, alternatively ask, state what is meant by a substance that is chemically combined with water, or state one word that can describe a substance that's chemically combined with water. You can say hydrated. So write the formula of hydrated copper 2 sulfate. That is going to be Cu2SO4 5H2O. And you also have to remember that you also have to know the formula of hydrated cobalt 2 chloride, which is CuCO Cl7H2O. Alright, describe how this crystallization is done. So this crystallization is done by heating the solution to the point of saturation and leaving to cool. So this is a separation methods question. We have to know the method. Aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. Say why aqueous copper 2 sulfate conducts electricity. You have to say mobile ions, not electrons, because we're not talking about metals here. We're talking about ionic compounds. And what do ionic compounds contain? Ions. Give two reasons why the electrodes are made of graphite. So graphite, we know that graphite is inert, it does not react, so that means it will not affect the electrolysis, and also graphite conducts electricity, thus allowing the electrolysis to happen. Describe how the appearance of the electrolyte changes during the electrolysis of aqueous copper 2 sulfate. So it will change to lighter blue. Describe what is seen at the cathode during the electrolysis of aqueous copper 2 sulfate. Now we can't really say copper 2 sulfate or copper just like that. We have to describe what we can see. It's as if we don't really know. It's as if we don't know that copper is gonna be there. We are in the experiment and we're seeing what is going on, what is at the cathode. So we can see a pink solid. Write the ionic path equation for the reaction at the anode. This is a very common question and it has the same answer. For OH minus gives 2H2O plus O2 plus 4 electrons. State two differences seen if the electrolysis is repeated using copper electrodes instead of graphite electrodes. So the electrolyte will stay the same color because both the cathode and anode reaction counteract each other, and second of all, the anode dissolves. When magnesium nitrate is heated strongly, magnesium oxide is formed. This is called thermal decomposition. The equation for this reaction is shown. So state the change in oxidation number of nitrogen in this reaction. So what we do here is look at the Mg oxidation number and look at the O oxidation number. We know that the Mg is going to be 2 plus 2, and we know that the oxygen is always negative 2. Now look at the number on the bottom right. It's 3, so 3 oxygen, so 3 times the negative 2 times the 2 here, because it's multiplied 2 times, so it's going to be 3 times negative 2 times 2, which is going to be 12, plus we don't really know the oxidation number of N here, so it's going to be N2, 2x, we're going to make it x, 2x because there's 2 nitrogens equals to 0. Using algebra here, we can make x 2 minus 12 negative 10, bring it to the other side. 10 divided by 2 is going to be 5. So we have to include the plus sign, as I have emphasized a lot. In enthalpy changes and in oxidation numbers, we have to include the plus and minus sign to not confuse the examiner. So that's going to be plus 5, and we need to know the oxidation number of nitrogen here. So O2, negative 2 times 2, 4, negative 4 plus x equals to 0. X is going to be 4, so that's going to be plus 4. So that's going to be your answer from plus 5 to plus 4. Identify the element which is oxidized in this reaction. Now we don't we can be sure that magnesium is not oxidized. We can be sure that nitrogen is not oxidized. So what is the other element that could be oxidized? That could be the one oxidized. It is oxygen. Why? Because why do we know that magnesium or nitrogen were not oxidized? That's because neither of them gained oxygen. They actually lost oxygen. So the only element which was oxidized in this reaction was actually oxygen. Calculate the volume of NO2 gas at RTP formed when 7.4 grams of MgNO32 is heated. Use the following steps. So we calculate the MR of MgNO32. That's going to be 148. We can use a periodic table. Count the nucleon number, not the proton number. Calculate the number of moles of MgNO3 to use. We use the formula mass over MR to get the moles. Determine the number of moles of NO2 formed. The ratio of MgNO32 to NO2 is 1 to 2. So we just multiply this to get the number of moles of NO2 formed. So that's going to be 0.1. So how do we determine the volume? We use the formula moles times the moles in 1 mole of gas. That's going to be 24. And since we want to convert to centimeters cubed, now if we just do 0.1 times 24, we're only going to get the answer in decimeters cubed. But since we want the answer in centimeters cubed, so we have to multiply it by 1,000 to get the centimeters cubed from decimeter cubed. That's going to be 2,400 centimeter cubed. Magnesium oxide MgO is an ionic compound. Complete the dot and cross diagram in figure 4.1 of the ions in magnesium oxide. Give the charges on each of the ions. So this is a really simple drawing question. We just have the atoms Mg and O, so we just have to draw another line. Usually it's only one extra line you have to draw. There's not much, but you need to double check using the periodic table to see if the atom has more than 1 or 3 shells. So Mg is going to be 2 plus, O is going to be 2 minus. Why? Because Mg has 2 valence electrons and oxygen has 6 valence electrons, so oxygen needs 2 and Mg needs to lose 2. And do not forget to make the X with the O, make the X with the O, or you can also make them not really together. Oxygen is a covalent molecule. Complete the dot and cross diagram in figure 4.2 of a molecule of oxygen. So when we see oxygen is a covalent molecule, remember that one of the double bond molecules are actually O, oxygen, O2, and we know that the triple bonders are actually nitrogen, so N2. And notice that actually the number of bonds that an atom can make is actually determined by the number of valence electrons it needs. So oxygen, since it needs 2 more electrons, it can form double bonds. And since nitrogen needs 3 more valence electrons, it can do a triple bond. But only remember that is only with one other atom, not 2. So we do the normal double bond, we do the dot and cross pairs, 2 dot and cross pairs, bonding, and we do 4 non-bonding pairs of electrons on each oxygen atom. That gets us the 2 marks. Hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicles. Name the substance which combines with hydrogen in a fuel cell. So we know it's actually a hydrogen oxygen fuel cell. That's what it's usually called. So it's going to be oxygen. Give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. So remember that hydrogen is flammable. And since hydrogen is flammable, and we don't want the car to explode, so hydrogen is actually hard to store. Its advantage is that it is more efficient. Hydrogen gas can be made from petroleum by a two-step procedure. Step 1. Petroleum is separated into different components. Large molecules obtained in step 1 are converted into smaller molecules, including hydrogen gas. Name the process used in step 1. Fractional distillation. Name the process used in step 2. Catalytic cracking. Now, uh, recently there's actually a trend in the exams that needs the inclusion of catalytic with cracking. It's like structural isomers. You have to include structural and isomer in the same sentence, so that makes sense, or is actually similar to the catalytic and cracking issue. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of the ester methylpropanoate, CH3CH2 COOCH3. 1 mole of CH3CH2 COOCH3 contains 6.02 times 10 to the power of 23 molecules. Give your answer in standard form. So we want the number of hydrogen atoms. We got the number of hydrogen atoms here is 8, so we put 8 times the number of moles times the number of molecules in 1 mole, so we can get the number of molecules in half a mole of CH3CH2 COOCH3, and the number of hydrogen atoms too. So we can get 2.408 times 10 to the power of 24. It is not really a complicated question. It can be solved, but the 4 marker here is because it combined many different aspects in one question. For each of the homologous series shown, name a member that contains 6 hydrogen atoms. So 6 hydrogen and not carbon. When I first approached the question, I thought it was asked for 6 carbon atoms. So I came along and did the questions as 6 carbon atoms until I reached the carboxylic acids, which made me ponder and think, do I actually know the name for 6? So I then looked at the question again and actually needed 6 hydrogen atoms. So I rewrote everything. So just a side note to read the question carefully before answering, because you may discover that the question may be actually easier than you thought, or maybe actually harder than you thought. So for alkanes, for example, we used the general formula for this question. For example, alkanes CnH2n plus 2. So 2n plus 2 equals to 6. 6 minus 2 is 4. 4 divided by 2 is 2. The n is actually the number of carbon atoms, equals to 2. Was the prefix for 2 carbon atoms? Eth. So it's going to be ethane. So the suffix depends really on the homologous series. So ethane for alkanes, propenes, alcohols, ethanol, carboxylic acid, propanoic acid. Unsaturated alkenes are converted into saturated alkenes by reaction with hydrogen gas. State why alkenes and alkanes are hydrocarbons. Compounds only containing hydrogen and carbon atoms. That is literally the definition of hydrocarbons. It is in the name. So state why alkenes are unsaturated. They have a C to C double bond. Now, if they say what is an unsaturated compound, you can't really say they have a C to C double bond. The answer will be they don't have. They have a C to C bond that is not single. Maybe another may not be a double bond. Name the catalyst needed to convert alkenes into alkanes. It's going to be nickel. You have to remember the reactions in the alkenes topics. Explain why the conversion of alkenes into alkanes is an addition reaction. That's because only one product is formed. Natural polyamides are polymers made from amino acid monomers. Say the type of polymerization reactions that occurs when natural polyamides form. Condensation. Say the term given to natural polyamides. Now, polyamides means it's proteins. Natural means it is not nylon, because nylon is an artificial polyamide. An amino acid is represented as shown in figure 6.1. It shows you the amino acids, the amino acid with a very similar formula to the general formula. This is actually the general formula, but instead of the R, there's a box instead. Complete figure 6.2 to show the general structure of an amino acid. So we have to show all of the atoms and all of the bonds in the functional group. Now, a common mistake that students do is leave out the OH bond as this instead of this. Now, the right way is actually this because it shows the bond between the OH. So you can't really see the bond in the OH if you don't really include it here. Three different amino acids are shown here in figure 6.3. Complete the diagram in figure 6.4 to show the part of the structure of the natural polyamide that forms when three amino acids A, B, and C combine. Show all of the atoms and all of the bonds in the linkages. So we have to show the NHs, C double bond O, and also remember when you do the drawing, if you don't really know what happens, remember that it is a condensation reaction. And remember that in a condensation reaction, water is formed. That means an OH and one H from here is separated, is actually removed. So what will remain here is just a C double bond O and an NH, and they will be combined. And this is how we get the bonding structure. And also do not forget the continuation bonds and include the brackets just in case the examiner doesn't really consider the continuation bonds to be long enough. So yeah, that's just as a safety precaution. A mixture of the three amino acids A, B, and C can be separated and the amino acids identified using paper chromatography. Complete the equation for RF, tension value, tension factor. That is going to be the distance traveled by the substance over the distance traveled by the solvent. Now this is a very rare question. I think it has only been asked once in a lot of years. So this is a very new question that it is easy to solve, but when you have solved the paper and solve more than 90% of the paper and you see this question, you may be surprised and not really remember, but remember this is chromatography and we are measuring the RF value. And what is the RF value? It is just the distance traveled by the substance over the distance traveled by the solvent. Now we got a sample of the mixture of the three amino acids A, B, and C is placed onto the baseline and a chromatogram is allowed to develop as shown in figure 6.5. So this is a chromatogram and we are asked, explain why the baseline is drawn in pencil. So why don't you draw it in pen? Don't you realize that when you draw something or write something in pen, you can move it or you can actually stain it further, and the ink of the pen will move or something will move around the pen line. But in pencil, it doesn't move. Why? Because pencil is insoluble in water. So state the type of substance used to make the colorless amino acids visible on the chromatogram in figure 6.6. That's going to be locating agents. Explain why in figure 6.6 only two spots are seen from the mixture of three amino acids. An amino acid has the same RF value as another amino acid. Suggest how the experiment can be changed to separate all three amino acids. Use another solvent because the amino acids may have different retention values because the other solvent may have a different solubility, may have a different speed of going through the paper. So that's going to help separate all the three amino acids, hopefully. And we have finished the paper. Thank you very much for staying until now. Actually, this paper was really interesting, and I mean, it's a very good thing to have solved this paper again. It reminded me that there are like new questions. If you weren't really, if you were in 2024 and you were solving this paper for the first time, this would have been a surprise for you, because you had to go through these types of questions: a ratio, and rare questions, like write the formula of hydrated copper to sulfate, Cu2SO4 5H2O, and other rare questions such as these ones: the number of molecule, the number of hydrogen atoms, the alkenes. This question, 6 hydrogen atoms, really employed algebra here, and also asking the to draw the general formula, structural formula, and this question exactly, specifically, and also about chromatography in particular. Uh, pretty new questions, like the pencil is insoluble in water and the amino acid has the same RF value, but it can be solved logically using the definitions and using previous knowledge of chemistry. Thank you very much for staying till now and hearing my review of this paper. See you later.